Let's proceed. Here we go. We're going to use U substitution in order to figure out the antiderivative, the integral, indefinite integral of this. Now, if you're looking ahead at the next problem, which I'm going to write here in just a second, you're going to realize that they are very similar in their structure, but there's a subtle difference that's going to change everything about the way that we simplify these two. So the next one, actually, I know I'm getting ahead of myself, but work with me on this. Go ahead, work with me, is this. The dx actually is in the numerator, if you're following along on the paper. The dx is in the numerator, but I can bring it over here, just for the sake of what we're used to seeing. Okay, let's start by identifying, in the top one, what our inner function is. And in this case, our inner function, loud marker again, is 9 minus x squared, and the derivative of that is negative 2x dx. And that's fantastic because that means that all I need is a negative 2 right here, or I could change this to just be x dx. That's what I'm going to do because that's the way I've taught this. And so we'll have negative 1/2 du. So basically we're dividing by negative 2. It's the same thing. So if you're going to proceed with the whole highlighting, color coordinating sort of thing, then we are going to rearrange a few things. The biggest thing happening is that we have somebody square rooted in the denominator. Who gets square rooted in the denominator? Well, you does, or you did, or you are, or something. So, you. Okay, so if we're going to color code everything, and I will briefly, don't have highlighters for this, but this right here is u, and the biggest thing happening is that somebody got square rooted in the denominator, like I said, and everything else, which would be x dx, is negative 1/2 du, and you can write it in lots of different places. I'm just going to put it right here. That's normally not the way it's written. You could put the negative 1 in the numerator, the 2 in the denominator. You can put the du out here. You could factor the negative 1/2 out. There's lots of things you could do. Okay, we're going to proceed with this problem in a minute, but I want to compare it to the next problem. So we're kind of doing two problems at once and then talking about how this idea falls apart here. So if we did U substitution using the same U as we did on this one, if we were like, oh, U is 9 minus x squared, and we're, oh, there it is, 9 minus x squared, then what's du? Negative 2x dx. You don't have an x. You don't have an x that you could use to say, oh, well, this is, where's my red pen? This is this. So because we don't have an x, this whole argument is going to fall apart. So we're going to have a different strategy for this one than we do for this one. It's going to happen a lot. You can see a structure to this that's going to look a little similar. Actually, while we're talking about this one, over here on the side, let me get there quickly. We're going to write a formula down that's going to help us with this one when we get there. I do want to do both of these problems kind of simultaneously so you'll see their similarities and differences. So the derivative, once I write this, it's going to look kind of glaringly obvious, I hope. The derivative of arc sine of x is 1 over the square root of 1 minus x squared. And I hope that structure looks enough like this to where you can say, maybe I can do something with that. And we will in a minute. Now, I realize that this kind of looks like that as well, but again, notice that the derivative of u should pop up somewhere else in the entire integral that you're dealing with, and it does. I had an integral of negative 2x, and so I have the x. I could just divide by negative 2. Don't have that luxury here, because if I went through this whole process, I'd have negative 2x dx, and then what about the fact that I don't even have an x? Like, it's not going to work, right? So let's proceed with the top one. We'll come back to the bottom one. Again, kind of doing two things at once. So let's do a little bit of rearranging. This is really the integral, negative 1/2. This u is in the denominator, so it has a negative exponent. It's square rooted, so the exponent is 1/2. So it's u to the negative 1/2 and du. So we will add 1 to that exponent. Old coefficient divided by new exponent, and then don't forget your c. So my final answer for this one, the top one, top left on your paper, is negative u to the 1/2. You can call it negative square root, I'm not, and then plus c, and u is 9 minus x squared. And if you wanted to, you could take the derivative of this to make sure that it works, and it does. It does. It does. It does. Very quickly, I'm going to do it. I had to stop and think my way through it. Let's take the derivative of this just to make sure we get that. So negative times a half, that'd be negative 1/2, and then 9 minus x squared. Subtract 1 from that. And then we will multiply by the derivative of this inner piece, which will be negative 2x. The c, derivative of that, goes away. And negative 1/2 times negative 2 would be positive 1x. And then 9 minus x squared to the negative 1/2. And sure enough, that is that. It works. Okay? It's standing in your way so you can't see it. We just found the derivative to check our answer. You don't always have to do that. So now we get to the tricky one. Dun dun dun. That was the ominous music. Okay, again, same thing I've said twice before. This argument doesn't work here because we don't have an x. So what I'm going to do is try to make this look like that. And one of the glaring obvious things is that I have a 1 here, and that's where I should have a 1, and here I have a 9. This is not the only way to think about it, but I'm going to continue to work through this before I ever even identify what u is. This one's not going to be obvious, but once you've done a couple of these, you'll realize it. So here we go. The integral of 1 over square root of, and then we'll have a dx. And again, the dx can go in the numerator, it can go off to the side, either way. So I want this to be a 1, so let's make it a 1. And I can't just do that. I'm going to factor out a 9 in order to truly do that, so 9. And I'm going to factor a 9 out of this, so I'm going to have x squared over 9. There we go. And now they still don't look alike at all, but they're about to start looking a little more similar. So let's keep this process going. We're going to have 1 over, okay, well the square root of 9 is 3, so we're going to pull a 3 out in front. So 3, and I'm standing in your way, sorry. And then 1 minus, and I'm going to go somewhere with this that may or may not be obvious, but here's where we're really going. I need there to be something squared. Now normally it's like, oh, it's x squared. Yeah, that's great. I need it to be a function squared. And that function is, well, let's just be real honest. It's x that's squared and 3 that's squared. So I'm going to treat this like x over 3 squared. Okay? So now this doesn't look like this. And you're probably like, well, why'd you do it? Still don't look alike. But it's getting there. And when you see where it's going, hopefully it'll click for you. It'll click like this marker when I put on the lid. There. So I'm going to factor a 1/3 out because I feel like it. And we're going to have 1 over the, oops, I left a square root off of this thing. Whoa, that's a huge mistake. There we go. Okay, I apologize. Make sure you put that in there. I left a square root out. The 3 is outside of the square root. This 1 minus x over 3 all squared is in the square root. And let me point out something. Common mistake, people say, oh, the square root of 1 is 1. The square root of this thing squared is, no. Because of the subtraction, I can't do it. I can do it for this 9 because this is 9 times that stuff. Can totally do it. These are factors. Just saying. Anyway, back on topic. Left my square root off. Man. Internally, I'm like, man, why would I do that? X over 3 squared and then dx. All right, where in the world is this going? We haven't even identified what u is yet, or what you are. Anyway, we haven't identified u yet, but we're about to. We're about to. And at this point, it's pulling the 1/3 out. This looks a lot like this, but there is an inner function, and that inner function is x over 3. Now we know what u is. So all this work led us to here to where we're saying, oh, u is x over 3, so the derivative of u is 1/3 dx. The 1/3 was factored out. It works though. So I'm going to continue moving forward with this. Here we go. So this work is going to come down here. And we have the integral, and we're going to do some little highlighting stuff. So what's the biggest thing happening? Well, the biggest thing happening is a lot of stuff happening. The biggest thing happening is 1 over the square root of 1 minus somebody squared. 1 over the square root of 1 minus somebody squared. And I have everything I need. All right, watch this. Watch this. If we're going to go with our little highlighting scheme that we've been doing, x over 3 is u, And let's use red. Let's use this little red. 1/3 dx, 1/3 in dx is, drop my pen, du. Okay? This is that. They're the same thing. So all I'm going to do is, instead of saying, oh, the derivative of arc sine x is this, now the antiderivative of this is arc sine of x. Actually, it's arc sine of u, and then plus c, of course. So this is arc sine of u, and then plus c. Okay, if your question is where'd the 1/3 go, I don't need the 1/3. There's your 1/3. 1/3 dx is du. All right, we're ready to plug our x over 3 in for u. So we have arc sine of x over 3 and then plus c. And that is it. Now, there are some formulas that take this idea and go a little bit further with it, just in case this was a function. Like if it was a u, then you would have du elsewhere. There's all kinds of things that we could do with that. I think this is a sufficient way to begin this process of identifying the difference between these two without getting into those other formulas. Those other formulas are, just for your reference, are on a lesson called, it was the previous lesson, Antiderivatives and Definite Integrals. And on the page, beginning of the second page, we have some really interesting things. Let me get right in front of the camera with it. We have some really interesting things like this. We could have used this formula for it right here. Totally could have. So all the work that we did, if we know this by heart, we could do it. So let me point out something here. We have a squared minus u squared. Normally there's a 1 there, okay? But now we have a squared. In this case, a squared is, watch where I'm pointing, 3 squared, which would be, of course, 9. So a squared, see where my thumb is 3 squared. X squared is, well, u squared. And so the final answer is arc sine of u over a, which would be x over 3. And that's exactly what we got right there. Right there. Okay? More than one way of doing this.